Hello, ladies and gentlemen. I just wanted to provide another example for you to check out. So this is actually number 3, I think, if you are looking on page 186 of your book and you want to follow along, okay? So this one is more closely going to resemble the problems on the homework. I think it's letter B and letter C of the front side. And the first thing that I did was realize that the original was in quotient form, and then I factored the numerator and denominator. And when that happens, then I saw that this factor, whoa, that's kind of big there, that this factor x plus 4 will cancel in the numerator and denominator. And so that's what gives me the whole, or the removable discontinuity. The whole will occur at x plus 4, but that's a factor. So to find the x value, I actually set it equal to 0. And that means the whole is at negative 4. So if we come down here and take a look at the ordered pair, it will be negative 4 comma something. I still need to figure out what that value is here in a second. But for the time being, now I'm going to take whatever I have left. Unfortunately, y equals 3x minus 7 divided by x minus 4 is still quotient form. So now we have to do long division. So I'm sorry, it isn't in transformation form. We have to go ahead and do that long division to make that happen. Okay? So we're going to divide 3x minus 7 by x minus 4, and we will see it goes in there 3 times. That gives me a 3x minus 12. When I switch, bye, that's a 5. As we discussed in class the other day, let me choose blue. Whatever value is down here, all alone, that's A. Up top, that's called king of the hill. And then this is the H value over here. Okay? So that gives me the transformation form y equals A, 5, over x minus h, which is negative 4, and then the k value is plus 3. Okay? So now I'm going to substitute this x value in right here, and that'll give me the y value. So it's going to look like this. Y will be equal to 5 over negative 4 minus 4 is negative 8 plus 3. I'm going to type that in the calculator. Hola, Manuel! Alright, sorry everybody. So if you heard, that was my good friend Manuel, the janitor. So he was just stopping by to say hello. But then I found the y value is 2.375. So that's right here, 2.375. That means you actually go to this ordered pair on the graph, negative 4, 2.375, and you draw a hole right there in that section. That didn't look very good. Let's see here. Negative, what did it say? Negative 4, 2.375. There's a hole in that section. Okay? Now, we still have a lot of other work to do. We've actually got to go and find the other points and all that kind of stuff. But first, I would like to identify the asymptotes, as we talked about earlier. The first one is coming from the value of h. That is the vertical asymptote, so that'll actually be at x equals 4. If you go on the x-axis to 4, we will graph this. Boom, 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 boom. Up, up, up. Then the, let's choose green. Then the horizontal asymptote comes from whatever the k value is. So this one was h and this is k. The horizontal asymptote will be at y equals 3. So that's right here. Boom, 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 boom. Like that. Okay? Now I'm going to have to go to the next slide to actually find those ordered pairs, so bear with me one second here and I'll get that all set up. Alrighty, so now I have shown you up here at the top both the tables for the left and right sections of the parent function, and now we're going to transform it. So based on the h value, I'm going to go ahead and add 4 to every x value. I'll do that first. Then there are two transformations taking place at every y value. First, you have to multiply by whatever the a value is, so I'll go ahead, that'll do the vertical stretch. We're going to multiply it by 5, and then second, we need to apply whatever the transformation is of k. So the second thing I will do is, sorry, try and change the highlighter color here. I guess I'm not that smart. Second thing I'm going to do is apply the plus 3. Okay, so we'll go ahead and do those calculations quickly. So now that I have all of the points graphed, I can go ahead and go back and connect the rest of the points with the hole. So if you notice here on the left side, it will curve up. Once you get to the hole, do not go through it. Actually, just keep cruising on the other side, to the left side of it. Then here on the right side of the graph, it'll curve down, and then it'll keep going very, very, very close to that asymptote. So the new thing for today was this removable discontinuity over here on the left side of the graph. We had to factor, then cancel, then we subbed it back in to find the value.